Hello everyone. In this video we will cover section 4.2, the addition rule of probability. This is the formula that we will be using. So let's see what each element means. The happy face means OR. This side is telling you what is the probability that A will happen or B will happen. The sad face means N and other things that I will explain right now. N means that these two events happen at the same time. This is very important. Now, this square with the two circles inside is called a Venn diagram. It will represent the sample space, and the two circles will represent the two different events. To make things very easy to follow, let's say that the two events we have, A and B, stand for this. Let's say that A means American and B is any person that likes bacon. Okay, you should always start with the middle, which is this, and this will be all the people that are American and like bacon. So the two things have to be true at the same time. This part will represent all the people that like bacon, but they are not American. Remember that the sad face means N. When it's combined with a complement, you usually gonna say is this, but not this. Remember that the A with a bar means the opposite of American. So these people are American, these are not American. Now this side will represent the people that are American, but they don't like bacon. And these people outside, this and this, are the people that are not American and also don't like bacon. This can also be written like this, but it's easier to look at this way: people that are American and don't like bacon. For these problems, if you do exactly what I just did right now, if you do this one first, then this or this, doesn't matter, and then this one, then it will be very easy to answer all the questions like you will see in a little bit. This is the official formula. There is a special case to this where this is not here. If this is not here, that means that the two events are mutually exclusive. Notice how it's missing this part. So mutually exclusive means that this is equals to 0. Remember from the last section, if the probability of something is equals to 0, that means that this will never happen. So for example, if you roll a die, only one, and let's say that A represents the event of getting a 4 and B represents of getting a 5, these two events are mutually exclusive, because if you roll a die, you will never get a 4 and a 5 at the same time. That is in the same time. That is impossible. Notice how when they are mutually exclusive, it's obvious that they have nothing in common. My favorite example is this. Let's say that this represents honest people and this represents politicians. You will never find a politician that is honest, and no honest person is a politician. So these two are mutually exclusive. Exclusive. Let's do an example. Let's say the Campton College has 75 full-time instructors, and of those 75, 50 own a dog, 35 own a cat, and 20 own both a dog and a cat. I told you that the key to making these problems easier is to complete this first before you answer any of the questions. Let's say that this represents the dogs, this the cats. I told you you should complete this part first, which is what they have in common. The problem is telling you that 20 of them own a cat and a dog. Since there is 50 people that own a dog, and you already have 20 here, that means that there is 30 here. Recall what this means. These are the people that have a dog, but they don't have a cat. And together, it has to add to 50. Another way to figure this number out is you just do 50 minus 20, it will give you 30. In the same way, this represents the people that have a cat, but they don't have a dog. There are 35 people that own a cat. Since we already have 20 here, that means this is 15, or it has to be 15. Now, how many do we have so far? If you add this plus that, that's 65. But the problem says that there is 75 people in here. So that means there is 10 outside. And remember, these are the people that do not have a dog and do not have a cat. So there is 10 of them. Once you have completed the Venn diagram, which means now you have the sample space that you can solve any of the problems. Part A is the addition formula, or the happy face. If we follow the formula, this is telling you this should be the probability of D plus the probability of C minus the probability of D and C. You already have all the values. This one is 50 over 75. This is 35 over 75. And then the last one is 20 over 75. If you add and subtract this, you get 65 over 75. And that's it. If you need a numerical answer, just use a calculator and round the answer to 2 decimal places. Notice that if you add this value plus this one gives you exactly 65. So the answer to the happy face is always going to be these 3 separate numbers. So that's another way to check that this is correct. Part B and part C are actually pretty easy. You don't have to use any formula. The answer is already here. This one is asking you how many people have a dog, but they don't have a cat. Remember that this could mean but. So in this particular case, you see that there is 30 people that have a dog, but they don't have a cat. And that's it. That's the answer. Part C is asking how many people have a cat, but do not have a dog. So you cannot count these ones. So it has to be 15 over 75. And that's it. Again, if you needed to input this in the computer, it probably has to be a decimal, so just divide this using the calculator and use 2 decimal places. Part D is actually the trickiest one, so let's leave that to the end. Part E is saying how many people don't have a dog and don't have a cat. Well, the answer to that is 10. So this is 10 over 75. And that's it. End of the story. Now, notice how part A and part D are very, very similar. The only difference is that D has a complement on top. For 1 second, just pretend the complement is not there. Then the formula will be identical to the one in part A. But they're not the same. Notice that the only one that has the complement is D. So therefore, just put a complement for the letter D. So this one and this one. Now, this one is asking you how many people do not have a dog. These people do not have a dog, and this one do not have a dog. So this will be 25 over 75. Part C says how many people have a cat. Well, all of the people have a cat, which is 35. And the last part is asking how many have a cat but do not have a dog, which is this value right here. That will be 15 over 75. If you add everything, you will end up with 45 over 75. And that's it. If you didn't get that one, here is another chance for you to redeem your sins. Alright, the difference between this problem and the previous one is that the numbers are given in decimals instead of whole number, but the process is identical. The two events here are Californian and Republican. The problem is telling you that 63% are Christian and 30% are Republican, and 18 are both Christian and Republican. Remember that you need to complete this before you attempt to solve any questions. This is telling you that 18% are both Christian and Republican. It also tells you that 63% are Christian. Well, if this is 18, then that means this value, 0.45, plus this one will give you 63. Remember, to figure out this value, all you have to do is subtract 18 from 63, and that will give you 45. But more importantly, you need to know what this means. Remember, this represents the people that are Christian but are not Republican. Using the same logic, this number will be 0.12, which this represents the people that are Republican but are not Christian. Then outside are all the people that are not Christian and not Republican, which in this case will be 0.25. Why? Because the whole thing has to add to 100%. Remember, the sample space is everything, so everything has to add to 100%. Once you have all of this, you can use the same formulas like the previous example. Part A, again, the happy face, is asking you what's the probability that C will happen or R will happen. Just write the formula again. And now you have all the information. All you have to do is plug it in. What is the probability that somebody is Christian? 63%. That somebody is Republican is 30%, and that somebody is both Christian and Republican is 18%. Once you add and subtract the whole thing, this is 0.75. Again, remember that you can check that this plus that has to be exactly equal to this number. That's one way to verify that you are doing everything correct. Part B is just asking what percent is Christian but is not Republican. So you already have the answer here. It's 0.45. Part C is asking what percent is Republican but not Christian, which is this one right here, 0.12. And part D again is the trickiest one, so let's leave this to the end again. And part E, it says what percent is not Republican and is not Christian, which is this number right here. So this will be 0.25. Let's do part D. Remember that this is very similar to part A, except for the complement in one of them. So just rewrite the formula and make sure that the complement is only on the letter that has the complement, which in this case is Republicans. You already have all the information in here or in here. If the probability that somebody is Republican is 30%, which is here, and it's also given here, then the probability that somebody is not Republican has to be 70%, which you can also see from here and here. If you add these two, it will give you 0.70. The probability that somebody is Christian is 63%, and the probability that somebody is Christian but not Republican, remember it was 45%. Once you simplify all these values, the answer is 0.88. And that's it. The questions can also be asked in a table like this. The first thing you need to do is to add all the rows and all the columns. You should stop the video and add all the rows and all the columns yourselves, and you will get this. Here the total is actually 310, not 300. 10 students added the class late. As you can see, this is very simple. All you have to do is add these rows and these columns and then the total. To find the probabilities is very simple. Part A is asking you what's the probability that a chosen person is Republicans. Well, you have 95 Republican, so the answer will be 95 over 310. And that's it. Let's say that the question instead asks this: what's the probability that the person is not Republican? That's the complement. Well, these people are not Republican and these people are not Republican. So if you add the two, this will be 115 plus 100 divided by 310, which will be 215 over 310. And that's it. In part B, we need to use the happy face formula. How do we know that? Well, the key to that is this, or. Remember, the or is going to imply the happy face. Here the question is asking what's the probability that the person is Christian or Democrat. Write the formula out, so this should be Christian plus Democrat minus all the people that are Christian and Democrats, or all the people that are Democrats and Christian. Then just get information from the table. how many Christians you have? Well, it's 110 right here. Christian is 110. How many people are Democrats? Democrats are 115 divided by 310. And then finally, how many people are both Christian and Democrat? This value 30. So this will be minus 30 over 310, which is 195 over 310. That's it. Next one says, what's the probability that a randomly student is Christian, but remember that but is also the sad face, but the person is not Republican. In this case, there's no need to use the happy face formula. All you have to do is look to the table. This one is saying that the person has to be Christian, which is this right here, but the person cannot be Republican. So therefore, all you have to do is get rid of this value. And what do you have left? 30 and 20, which will give you 50. So this will be 50 over 310. And that's it. The next one is not worded the best way possible, but this is what it means. It says, what is the probability that a randomly selected student is not Christian, or he or she is a member of the Green Party? So this is what it means. Then here you do need a happy face formula. So this will be the probability that somebody is not Christian plus the probability that the person is a member of the Green Party minus all the people that are not Christian but belong to the Green Party. All the information is on the table. Not Christian means that the person is Muslim or other. So in this case is this 2, which is 200 or 310. Now it says that it has to be a member of the Green Party. Well, there is 100 members of the Green Party, so this will be 100 over 310. And then finally, all the members of the Green Party that are not Christian. Since these people are Christian, you get rid of those. So the only people left that are members of the Green Party but are not Christian are these 2, which is equals to 80. So this will be 80 over 310, which the total is 220 over 310. And that's it. Remember, if you were doing a quiz online, most likely you will not input the answer like this. Divide this over this on the calculator, run the answer to whatever the question is asking, and just input the answer. And that's it. Finally, let's do part E. Part B requires the happy face formula too. It says, what is the probability that a student is Muslim or Christian? So the formula is asking you to do this, Muslim or Christian, which will be Muslim plus Christian minus Muslim and Christian. Okay, how many people are Muslim is 95, so this will be 95 over 310. How many are Christian? Christian was 110 over 310. Now notice that this part is going to be equals to 0. Why? Because they are mutually exclusive. You cannot be Muslim and Christian at the same time. So therefore this is equals to 0. This is the special case where two events are mutually exclusive. And all you have to do is add these two. So this will be 205 divided by 310. And that's it.